This conference will now be recorded.
Very good evening, students. Today we are continuing the chapter System of Particles and Rotational Motion. Here today we have picked up numerical problems from moment of inertia and rotational motion. This particular section, and these questions, as I have been mentioning, that these questions are actually picked up from JEE Mains previous papers. So let us start our discussion today. So the first problem is from JEE paper, JEE Main paper 2019. Now let us read the problem and then try to solve it. A solid sphere of mass capital M and radius capital R is divided into two unequal parts. First part has mass of 7 by 8 m and is converted into a uniform disk of radius 2r. The second part is converted into a uniform sphere, solid sphere. Let I1 be the moment of inertia of the disk about its axis, and I2 be the moment of inertia of the new sphere about its axis. So the ratio of I1 to I2 is given by 285 or 185 or 65 or 140. So this is the question. I'll repeat once again. So in this problem, it is stated that a solid sphere of radius r, capital R, and mass capital M is divided into two unequal parts. Divided into two unequal parts. Then one part is converted into a disk, and the other part, so converted into a disk of radius 2r, and another part is converted into a new solid sphere which has moment of inertia 2 about its axis. Now we have to find out I1 and I2. I1 is the moment of inertia of the disk, and I2 is the moment of inertia of the sphere. So to solve this, let us first see, there was a big sphere. Suppose I'm just trying to pictorially demonstrate, and then it is divided into two unequal part. One has, so this is this is sphere, okay, and another part is sphere alone, okay, sphere, and this disk has radius 2r, but we don't have this in the problem. So radius of the sphere is not given in the problem. So what is moment of inertia I1 and I2? So moment of inertia of I1 is the moment of inertia of the disk about its axis. That means it is mr square by 2. Okay, so but the mass is given as 7 by 8. Okay, 7 by 8 mr square. Here this radius is 2r for the disk given. So if we want to find out moment of inertia, let me write. So you have to find out moment of inertia, that is the moment of inertia about the of disk about its own axis. So that is m r square by 2, and that should be 7 by 8 m. Mass is actually 7 by 8 m. Let me, okay, so mass is 7 by 8 m, and r means 2r mr square by 2. Okay, so this is 7 over this 4, this 2 will cancel, and another here. So 7 by 4, 7 by 4 mr square. This is one part. Second part is the solid sphere. So we don't know the radius, we don't know the mass, etc. Mass may be known. Mass is like this, m18 by m, because the other mass was 78 by m. So this mass is like 1/8 of the original mass. So we know the mass of that. So E2 is equal to I2. Sorry, I2 is equal to, let us say, m by 8. This is the mass, r square 2 by 5. Okay, this small r we have to find out. Now what is the small r? How do we get this r of the sphere? So to get that, we need to rho v is equal to 1 by 8 m, volume of the sphere, and this is rho is the density of the mass. Now we need to find out what is this rho. Rho is mass per unit volume. So we have considered this as, so this is the volume. Now V, sorry, this is the density, total R. So this, I have to use this space itself. So let me erase this part. So we have got rho into V is equal to 1/8 of the mass. Then we can write what is rho. Rho is m by 4 by 3 pi capital R cube. This is the rho mass per density. So if we multiply the volume, four by 3 pi small r cube. Okay. So we get the mass of the sphere. So this 4 by this will go away. So we'll get actually m, this is capital R cube, small r cube. So this is the one. Now we can actually equate this and this. From there we'll get a relationship between small r and capital R. I'll in fact go to the next last page. So 1/8 m is equal to 4 by 3 m pi. Sorry, this will be actually m capital R cube by small r cube. Okay, m goes off. R cube is equal to capital R cube by 8, and R will be so this cubed root of 8 is 2. Sorry. Here it will be 2. Okay. So we have got the radius now. By getting radius, what we can do? We can actually get the mass, and then we can write 2 by 5 m by 8 r square. Okay. So actually I have very less space here. I need to just remove few parts over here. If I require, I'll just come back to this equations. For disk, we have got already this. So I2 is 2 by 5 m prime 8 small r q r square. So this r is given by capital R by 2. Okay. So if we put it here, this is square, this is 4. So like 2 by 5 m already there. R square by 4. Yes, R square by 4. Here m prime also has to be changed. That has to be 1 by 8. Okay, 1 by 8. Then what we get? M R square by 40. Okay, if you look here, sorry, 80, m r square by 80 will get. Okay, now if we take the ratio, then I 1 by I2, I1 is 7 by 4 mr square, and I2 we have got mr square, so this will give you 140. So this is Newton meter square. Let me not write the unit here. So I hope you have already understood this, what we have tried to do. So one is disk, another one is sphere. Okay, and the mass was given as 1/8 of the mass of the main sphere. Okay, so this ratio is 140. That means this option will be the correct answer for this. Now this problem, this is again interesting. The moment of inertia of a solid sphere about an axis parallel to its diameter and at a distance x from it is Ix. So the moment of inertia of a solid sphere about an axis parallel to its diameter and at a distance x from it is given as Ix. We have to answer which of the following graphs represents the variation of Ix with x correctly. So this is a graphical problem. We have to solve it. Let us see what is the moment of inertia of a solid sphere, and let me tell you this. uh, See, there is a sphere. Suppose this is a sphere, and it's suppose a principal diameter. A diameter is this. Okay, so this is diameter, and it can rotate about this diameter, and the moment of inertia about this diameter, if I write id, that can be written as 2 by 5 mr square, where r, capital R, is the radius of the sphere. Now you have been asked to see a moment, like calculate moment of inertia. Suppose first an axis which is, suppose this is x prime here, so this is x, moment of inertia about an axis which is parallel to the diameter and x distance away. This is the x distance away. Okay, so we know by parallel axis theorem this moment of inertia Ix will be the moment of inertia about the diameter, because this axis is parallel to diameter into mx square. If the mass of the okay, so this is mx square and id we know 2 by 5 m r square plus mx square. Okay, so I of x is basically a constant term plus mx square. Okay, so this particular term if I just take as constant, because capital R is constant, m is constant, 2 by 5 is constant, only this thing is varying with time. So see, this has a variation of parabola, and that parabola, since the m is positive, that has to be proportional to, so this I of x is proportional to x square. Okay, I of x is proportional to x square. So the moment of inertia about an axis parallel to the diameter of the sphere is Ix, and that is equal to 2 by 5 mr square plus mx square, where this mr square, like 2 by 5 mr square, can be taken as a constant term. Therefore, it is I of x is directly proportional to x square. Okay, so if that is the case, then it will be like a parabola. It varies like its path will be, or if I draw ix versus x, that will be a parabola. So there are two things. See here one parabola and here another parabola. So these are discarded. Well, option 1 and 2 is discarded because the graph has to be a parabolic graph. Okay, so that's the reason. Now there are two parabola. You can see that this is one and this is one. But then we have to now see whether I of x has some value at x is equal to 0 or not. See here, if I see for this term, the mx square term is there and plus a. This is a constant. This does not depend on time. Sorry, does not depend on x. So that's how this is a constant term. Even at x is equal to 0, there will be some value. From this we can understand. So even at x is equal to 0, this a will be 0. Okay. So therefore, m at m is equal to 0, a is not 0. Okay, the amplitude is not 0. Therefore, I of x will be a parabola, and that is represented by the second figure properly, because at 0 is equal to, at 0 the angular frequency will have some value, that is a is given here. So this is the correct option. Why this is not? Because it at 0 there is at x is equal to 0 there is 0 value of this I of x, but at the 0 position there should be some moment of inertia, since it is this one 2 by 5 mr square plus mx square. Now we'll go to the next page. So fourth option will be the correct answer for this question. So now another problem we are going to solve here. That is, a circular disk d1 of mass m and radius capital R has two identical disks d1 and d2 and d3 of same mass and same radius. As you can see in the figure, as you see in this figure, there is a disk d1 which has mass capital M and radius capital R. It has two identical disks uh, at the two ends of it, so d2 plus d3. They also have the same mass and same radius, attached rigidly at its opposite ends. The moment of inertia of the system about this axis passing through the center of d1 is so we know that moment of inertia of a disk about its own axis, that means about an axis which is passing through its center of mass, is given by mr square by 2. Okay, this is a circular disk, so mr square by 2. So we can find out the moment of inertia of this one very easily. Now, the D2 and D3, these are the rings at the ends of the ring D1, and the moment of inertia of those two about axis O1 or O prime. This axis is actually parallel to the diameter of the disk. So we can write, see, this is an axis about this we have to, so this axis is actually parallel to this diameter. So we can find out diameter plus m d square by or r square by mr square. So this is for this d2, suppose I2. So I2 is id, that means moment of inertia of this disk about diameter, so mr square by 4. Okay, and this has moment of inertia same, so we can multiply 2 actually. So let us write the total moment of inertia of this. So the moment of inertia of the system about an axis pass o prime passing through the center d1 and as shown in the figure will be, so id plus this, so this is 5 by 4 mr square. 5 by 4 mr square, it is the moment of inertia of each disk about this particular axis. So the total moment of inertia will be, so I1 plus I2 plus I3. So I1 we know mr square by 2, mr square by 2, and it has 5 by 4 mr square. So since this has 2, 2 2 has to be multiplied with this. So this we have to multiply with 2. So mr square by 2, mr square by 2. So it is actually, sorry, this will be 6m by 2. So this will be actually, no, not this one. This 2 will be cancelled out. Three m r square. It will be actually 3m r square. So we have got the moment of inertia of the combination. So this parallel access theorem, we will be applying parallel access theorem. This only alone we have to find out. Moment of inertia of only one about the center of mass O1 O. About this axis, the moment of inertia has to be the sum of the moment of inertia of this particular disk d1 with respect to its center of mass, like axis passing through center of mass. In other cases, the moment of inertia has to be okay. So we can see this will be actually the answer. Six m r square by 2, so it will be 3 m r square actually. Okay, so this will be the answer. So basically we have to apply parallel access theorem for these two disks. Okay, and this is anyway moment of inertia about its own axis. So this is another problem from moment of inertia itself, because any case you go, moment of inertia has to be calculated for rotational motion. So we have got another problem that we'll write the problem first, or let me just explain it what it is. You can see the figure. In this figure, there are two identical balls, spherical balls. These are actually identical spherical balls. Identical spherical. So these are two identical spheres. They're stuck at the end of ends of a rod. This is a rod. You can see that, and it has a length 2r. Then moment of inertia about this axis for the whole system. Okay, you have to find out that. So these are spheres, identical spheres actually. So sphere means it will have moment of inertia about its own axis okay, for both sides. Now this rod also has moment of inertia about this. Suppose that is I01. That has ml square by 12. L means 2r, so m 4r square by moment of inertia ml square by 12 for a rod, uniform rod. Okay, so we have got moment of inertia for the rod. We have got moment of inertia. That means God means we know moment of inertia of the circular disc. Now what is the question here? The question is, just a minute. Moment of inertia of the whole system you have to find out. That is the question. Okay. So moment of inertia of the whole system. So options are given in the question itself. So what would be the answer in this case? How moment of inertia would combine each other? So we have to now get the total moment of inertia by summing them up. I think I have done a small correction over here. M by 12. Let me. This is ml square by 12. M L. This is sorry. This is square. So m r square by 3. Okay. This is the moment of inertia of the rod. Now you have to combine them. So how to combine? Actually, moment of inertia can be combined like this. Total moment of inertia 2 2 plus I2. 2 plus I2, and I01 is 2 by 3 mr square. This I2 is 2 into 2 into 2 by 5 mr square. So this is no I'm yes, so this will be 2 into okay, so if you go let me just write once again this thing. See 2 into mr square by 3. Then I2 is the moment of inertia of each of them. Actually, this will be mr square again. So this will be sphere diameter. So 7 by 5 mr square. So this is I2. ID means I2. So this, if you solve it, I1 I had taken this one as for the rod. So this will be, I'm sorry, this is not 2. This is I1 into 2 I2. Okay. So 2 I2. I2 is here 2 by 5 mr square plus mr square. So this is 7 by 7 by 5 mr square. Mr square by 3 plus 2 into 7 by 5 into mr square. Okay. So if we do this LCM, 5 and this is uh, 42. So this will be 47 by no. Okay, let me just do it, repeat it because there was some calculation mistake. This rod, I'll write rod itself. Rod has moment of inertia m 2r square by 12. So this will be this 4, that means m r square by 3. I have two spheres at the end, so this much is r. Okay, so x is parallel to their diameter here, so each will contribute to moment of inertia. Suppose id I write, so 2 by 5 m r square plus m r square. Okay, parallel axis theorem. So 7 by 5 m r square. Okay, each of them will contribute this. Okay, Okay, so I think there is some issue with this. I'll just come back with this solution because the answer we'll be getting is not matching with any one of them. So we'll discuss this thing tomorrow or in the next class. Uh, there must be some. Okay, so some confusion is there with this. I'll just come back to you with this in the next class. I think I'll stop it here for today. Uh, we'll discuss few more problems, and today we'll stop here. So bye for today.